If anyone starts nodding off, I'll just assume you are in agreement with me. And we are talking about voice AI. So don't worry. If you're snoring, I'll just tag that as background noise, and we'll filter it out, right? So deep diving in, let me just, right? We are going to explore today on how we engineer voice AI to detect emotion, intent, and bias, specifically in Indian speech, right? And why that matters more than ever, especially, voice is becoming the primary interface for millions of first-time internet users, right? Let's start with what this complexity sounds like in real life, right? मुझे होम लोन चाहिए, but EMI कितना होगा? We all know the intent here is inquiry about home loan. The emotion, you are cautious, maybe anxious about affordability. Let's look at light velipindi, inverter charge unda, right? Again, a mix of Telugu and English, right? And intent, complaining on power outage, emotion, frustration, urgency, right? One last baby, right? Enak water connection problem irukku. Please fix it today, right? Calm voice, but if you know Chennai summers, you know the urgency, right? 3 languages, 3 emotions, 3 intents, right? The challenge is, can voice AI understand them, right? Not just the words, but the emotion, the message, the meaning, and the feeling. And in doing so, are we doing it fairly for every Indian voice, right? So that brings us to what we call as the triad of challenges. The first one being the intent, what the user really wants, right? The second is the emotion, how he feels, right? And third, the bias. Are we treating all the voices equally across languages and across accents, right? Many systems kind of stop at intent. They'll know what you're saying, right? They'll know that you might want a loan, but they might miss that you're frustrated or anxious, right? And sometimes the misinterpretation happens at cultural cue identification level. What I mean by that might be you might mistake loud joy for anger, right? And soft politeness for calmness, right? And imagine when this misinterpretation or misclassification happens in some accents or languages relative to others, bias starts creeping in, right? So solving one without the others isn't actually enough. So we'll have to look at how are we going to solve this together in our new voice agent scenario, right? And now, why is this especially hard in India? We have how many? 22 plus official languages, over 100 dialects, right? And a lot of code mixing is happening, right? English plus Hindi, Telugu plus English, right? Tamil and English. Accent shift, not just state by state, but we also see rural versus urban differentiation in accents. And emotional expression also varies. What do we mean by that? Sometimes loud celebration in one of our languages and in culture may sound angry to an algorithm that's been trained in the West, right? So without this cultural awareness, models kind of fail real users, right? And the next question, why to solve this now, right? India is becoming voice first right now, right? Let us look at some of the metrics. 72% of Indian internet users use voice assistants. Now the number is growing at 30 to 35% CAGR. And you can also see this voice commerce alone, conversational e-commerce as you may call it, is predicted to grow to $45 billion by 2030. And imagine 70% customers prefer voice, particularly for vernacular shopping journeys in India, right? We are not just talking of a tech trend, we are talking of an inclusion story, right? Voice makes the internet accessible to millions who never typed a query in English. Can you imagine, right? So this is inclusion that we are highlighting. And why do we need this transition, right? Our earlier focus and our old systems stopped at transcription. What does that mean? Speech to text, right? They could tell what you said, but not what you meant. So we are now looking at a full stack voice AI, starting with ASR for transcription, right? Automatic speech recognition, NLU, natural language understanding for getting the meaning out of the conversation, LLM for context, right? Contextual understanding, and human in the loop to catch whatever our machines miss, right? This is what actually transforms raw audio into actionable insights for most of us in business. So here is the full stack feedback loop that most of us kind of propose today in the industry. It starts from automatic speech recognition, where voice is converted to text. The text goes into NLU, right? We get the understanding of the content. Then you have your LLM doing the emotion and bias analysis, supported with HITL, right? And HITL in the cases where there is low confidence or high impact, and then we know and identify where we have to retrain, and this is the full feedback loop that we are talking about. Can we just look at each of these layers one by one, right? Let's start with ASR, right? Our first layer. It's an umbrella of technologies, approaches, guidelines, whatever you may give a name. The first is our wave-to-vector model. It's more a self-supervised learning model. It understands from raw audio waveform data, right? Then you have your conformer, CNN plus transformer. This is more to make your audio learning more robust to various accents. Then you have your recurrent neural network transducers. This is more for real-time transcription when there is a lot of streaming that's happening, right? On top of it, we do understand the need to adapt to various accents, the new developments and the enhancements that are coming in the form of X vectors that break a big segment into equal smaller segments for more accent mapping. And spec augmentation, this is more to identify or augment data for identifying noise, background noise, traffic, whatever, and only get to the real crux of the transcription. So at the end of it, we have a very clearly transcribed data, which forms the basis for our next step, right? So let's look at NLU plus LLM pipeline. So what exactly happens here is your multilingual embeddings are handled by IndicBERT and XLMR. IndicBERT is nothing but the Albert model for the Indic languages, right? Which maps your local languages into a similar semantic sieve that I call, or you can say similar semantic space. Then comes in your hierarchical intent classification. So broad intent to narrow, right? This is like, mujhe ticket book karna hai, you know that somebody is looking to book commute ticket. So you understand that it's a request at the broader level, it's for commute at the second level, interested in buying a ticket at the third level. Then comes your slot filling. Slot filling gets more details from the conversation, like where exactly you want to go to, from where are you traveling, what mode of commute, what do you want me to book, right? So this is what happens. NLU plus LLM pipelines actually provide a better contextual reasoning for code mixing and language queries. NLM kind of takes it further for more complicated, multilingual, multi-turn conversation, right? Now let's go to the next level, which is your emotion detection. How does it happen? This happens when we combine acoustic features, like what is the pitch, what is the energy. If you had noted the spectrometers, audiometers, right? There is something called as a Mel frequency septal coefficient, which is MFCC. This emulates the way human ear perceives voice, right? So we are trying to combine these acoustic features with the positive and negative words, the lexical sentiments, and on top of it, let's layer your cultural nuance understanding, right? So what does that mean? You are able to differentiate between loud joy and anger. You are able to differentiate between soft calmness and politeness, right? So so this is where your human touch or human annotation comes into being. So human annotation kind of teaches the model these slight subtleties, right? So let's go to the next level. So we looked at ASR, we looked at NLU and LLM. Third is how do you detect bias and fairness? The new metrics that are currently coming into being are, equalized odds, right? Subgroup accuracy, disparate impact. Across what? We want to measure these across various subgroups like rural versus urban, male versus female, language fairness, right? So if a rural version of a language lags 10% behind the urban counterpart, it just shows us where exactly your model needs to retrain, right? So this is how we kind of bake in bias detection and fairness into the architecture. And the last is how do we get to this HITL workflows? What exactly happens? First case, mostly the low confidence cases are redirected to humans, right? And the second level, they are reviewed by them. But primarily, many of these edge cases and low confidence cases are identified by models themselves through active learning, right? And when this happens, there is more cultural nuance built into your models, right? So you connect it back to the entire, feedback loop that we were talking about. What we see is that if we implement this complete feedback loop, right, in similar deployments, industry has seen 12% improvement in recall rate within 2 months, which is phenomenal, right? That's actually millions of calls better for customer interactions, right? Next, now we have done all this, the primary or the key point here is how do we discuss developer integration around this architecture, right? So there are a lot of APIs in the ASR layer that are provided, let's say wave to vector and so on. So what do? We kind of utilize these APIs to stream raw transcriptions or inject custom vocabularies, or if you're talking about a specific domain, let's say banking, healthcare, whatever, train the models on the specific terminology using these APIs. Second, the NLU plus LLM layer, right? Contextual understanding through REST endpoints, right? So if you say loan chahiye, weekend offer hi chahiye, right? You can pass the request to LLM to understand that there is a request and there are constraints, right? Can you understand both of them, right? And there are also, we can also build in emotion and bias modules. You can actually bake them into your CI/CD deployment pipelines, right? So that you have these metrics which kind of help you visualize where the bias is happening. And finally, automate your HITL in the loop, right? Model identifying which are those edge cases, which are the cases where the model is uncertain, and kind of get support from the human reviewers, right? And some key benefits that I see for developers from understanding this architecture. One, the entire stack that we were discussing or talking about is modular. You can independently upgrade your ASR layer. You can independently swap your LLM and without massive rewrites, right? That's one of the first benefits. Second, you are looking at continuous feedback loop, right? Continuous learning, your model is improving rapidly. And rapid prototyping, you already have your pre-tuned model for code mixed multilingual input. So that kind of reduces your model building time, right? And we are also having your bias and emotion metrics which are built in. And we are not talking about understanding today's conversation. We are building this architecture for future. Can it understand multi-turn, multilingual, complex conversations in the future for future context, right? In short, the major heavy lifting is taken by this architecture, right? You are not to be worrying about fair multilingual voice AI if this architecture is in place. And this frees you actually to focus on creating better user experience, right? Rather than worrying, is my voice AI fair, multilingual? Of course, you do understand that bias is not a one-time effort. Understanding bias, it's constant monitoring. But I do, kind of vouch for this architecture, right? Let's look at few key examples. Large telecom provider with multilingual queries, right? We all know the standard problems in such voice AI here, right? There is a lot of code mixing happening, a lot of emotional misreads. There may be rural-urban bias. But a hybrid AI has the potential to automate at least 30% of these calls, right? And it can cut your handling time by about 25% and reduce the bias parity, right? And look at another case in the context of citizen helpline, right, for municipal water and electricity departments. The biggest challenge is there's a lot of noise, there is ambiguous pipeline, there's a lot of accent-based bias. So if you can look at this particular voice AI architecture, we can see that there is almost 20% faster response time, a potential for 20% faster response time, where you automate classification, routing, and fairness parity, right? Few things that probably we can take away from this are, we need to work on diverse data sets. It's an investment that we must all consider making, and also think of multilingual models. Today in real life, we see a lot of services which are juxtaposing voice and text. Think about your models also looking at that in that context, right? Can we also adopt more, accent, neutral ASRs, right? Create more bias dashboards and bias audits, and build in a healthy HITL loop into your model, right? This is more for empathy and fairness and all that, right? The scale, the metrics that you had seen, the market opportunity that you had seen earlier, to actually reach that, we should definitely understand that there are millions of real voices behind. So understanding them becomes most important if you need to realize the potential behind those big numbers and CAGR and all that we were talking of, right? So let me just give a quick context of the organization that I come from, Next Wealth, and what do we do, right? So we do provide support for 22 plus Indian languages, right? And we do this at scale. And our annotators actually bring in a lot of cultural diversity, so they do understand cultural bias, emotional expertise, right? And we operate in secure ISO certified environments, right? We actually work for several organizations in the finance, e-commerce, and citizen services space, right? The human layer is what actually makes LLM-powered voice AI fair and empathetic, right? So for me, the takeaway from this is, in a land of billion voices, we're talking about Indian voices. Innovation is just isn't about hearing; it's more about listening, right? And definitely AI can't solve this alone, and human empathy can never be scaled. So can we build this architecture and the entire agentic AI in such a way that we build fair, inclusive voice AI for India, right? Thank you so much.
My name is Sarika Pal. I'm from EXL. If I go to the next slide. Okay. So a little bit about myself. I have close to 18 years of industry experience. And I've, if you talk about this AI and ML industry, right, I am lucky enough that I've seen how the industry has evolved, right? Back then it was just analytics. And I'm not sure, I think I can see a lot of young population, but people who earlier, who were there at that era, that time it was SAS, right? And probably we used to do logistic regression, simple regression. Then we moved to, okay, probably with text we can use NLP, some regex, BERT model. Then for generation was still a problem. I remember 5 years back I was with Microsoft, and one of the customers, they came to us, they said, okay, and that was a edtech company. They wanted to create a solution for university where for engineering drawing, right? Students used to submit their assignments, they wanted to evaluate and generate a report. That time it was difficult for us to generating something, right? And Microsoft was building a model called Turin, was not giving good results. So we had to scrap that project. But after that, when came to EXL and close to 2.5 years back, right? Suddenly GPT model came into the market and it was a big disruption. And like I had the journey of my career, if you see I'll just also talk about my company's journey, right? So it started with BPO, right? And I'll tell you how it has helped us now. So from BPO, which was mainly on the cost efficiency side, then analytics, obviously, then CX, customer transformation and experience. Then we focused on this data-led side. Why? Because this was the time, right? Initial years, we were collecting the data, which is very important to build any of the solution and deploy any of the solution, right? And that has helped us a lot in the recent years. For example, last year, my company released the insurance LLM. It's a fine-tuned LLM, what we were able to release with better accuracy as compared to the market models like, Mistral was there, GPT models were there. And the main reason was that we had the data. We had insurance data where we had a data sharing agreement with the customers for whom we were managing the BPOs, right? So the operations. So that's how it has helped us. So currently the company is focusing mainly on the data and AI-led solutions, and the investment is also on that side, right? So I'll also little bit talk about recently, if you see wherever the analytics who rate the companies in terms of how they are doing in data and AI side, we were the leaders this year and last year in Everest, HFS, ISG. There are multiple, analysts who spoke about us, and they have also mentioned the shift what we have taken from BPO to data and AI side. So in today's talk, I'm going to talk about Agentic AI, right? So as I said, right, from analytics to AI to generative AI, and these days, if you're a developer and a data scientist, if you're not talking about generative AI and Agentic AI, probably people think that you're not smart enough, right? Sometimes it's compulsion. Unnecessary, we have to talk about AI agents. Things which can be solved very easily using probably just SQL queries. There also we have deployed agents, because that's how the world has become, right? So I'll talk about why Agentic AI and AI agents are important, but also we should not just deploy it anywhere, right? Why it is important to assess the situation where exactly it is required, because when you're developing any Agentic AI solution, you're investing a lot of money there. Lot of money, bandwidth, resources, and when you see the outcomes, then it's a problem, right? And that's where we talk about the scaling Agentic AI. So last year, as I managed all the generative AI deliveries and Agentic AI deliveries for the company, I delivered 100 POCs, right? All the customers, they were gung-ho about Agentic AI, generative AI. I want to use it, right? I have got the budget, I want to use it. But how many have got into production? Not even 10%. Problem? They just focus on this very small problem. They didn't think about the entire infrastructure, the environment they have. They didn't think about how exactly the end users of the company, they are going to use it, right? How it can get integrated with the upstream system, downstream system, it is difficult. So that's why when we think about creating any AI agents or agentic solution, we just don't have to think about just the agents. Agent part is just probably the 20%, right? Because we are not building agent just to build agent. We are trying to solve a problem, right? Any business problem, we try to solve it. Then we think, okay, this is the problem, and we have to find a solution. What can be the best way to find the solution? Unnecessary, we never go to the customer and we say, okay, I have an agent, do you want to buy it? Nobody is willing to. Unless we say, okay, this is the problem, okay, I can solve it using probably agent, not agent, generative AI, not agent. I can solve it using just simple regex also, right? So that's why I think people get confused also, agentic AI and AI agents, right? Where to use it, how to use it. The simple thing is that if you have defined goals, you know what you want to do it, right? Probably the agents can be good option. agents where they can take some decisions also. If they have to you have to automate certain steps, you can create workflows. You can use any of the RPA solutions. That is good enough for you, right? If I go next, when we build any of the agentic AI solutions, the problem what we face, right? The first problem is complex workflows that require judgment calls and multiple steps. And the problem where lies is we get excited about AI agents. We create agents after agents. We create multi-agent system where the agents are talking to each other. But you just forget how complex system you have created. When you are running the entire solution, the latency is 6 minutes. If you have fired a query and you have to wait for 6 minutes, can you imagine, right? You won't obviously wait for 6 minutes for that. Second thing, customer says, okay, I have spent 1 million, but I had only 3 resources who were working on that. Their salary is much less than that, right? Then you have created again another problem, right? That of creating the agentic solution. And why this has happened? Because when we were building and deploying the solution, probably there were not enough monitoring metrics which were in the system. So when we monitor our solution, generally we do it post-deployment, right? But what happens during the development, that also important. Because your bias in the data, right? The cost. You know that, the models, LLMs, which are the foundational model for any agentic AI solutions, these are costly. If you are using open source models, probably you are spending on computes. If they are not open source, closed source models, every API called, it's costly, right? Then third is basically, I'm not going to read all of these. Probably I'll talk about some of the scenarios, right? Then the problem is that, as I was talking about, we have created a solution, probably the accuracy is not good. So generally, when we create any of the solution, there are 3 main factors of generating a solution, and that's where we cannot get the best out of 3. I mean, all 3 cannot give you the best result. Accuracy, cost, and latency. You can't say that, I want to create a solution which is 99% accurate, yes, costly, and latency is also good. Somewhere you'll have to compromise it, and that's where you'll have to think, when you are building a solution, what is the requirement? For example, if I'm working or creating a solution for a manufacturing company, where people are, the employees are working there, their safety is utmost thing, right? I cannot compromise on the accuracy. Even probably 99% is also not good for me, right? But I'm okay with the cost. I'm okay to spend the cost. I'm okay with the latency, right? So that's where I think you'll have to think about it, what exactly you are building and how exactly you are going to build it. So now when we deploy any of the agentic solution, and scaling is the problem because when we don't see the big picture, right? So there are a few ways what we can think about it, and that you must have heard about, the ops, ML ops, LLM ops, and these days these are agent ops, right? So what do they say, right? The first thing is that when you are creating your infrastructure architecture, it has to be modular. Why? So first of all, right, today I'm using GPT 4.5. It is giving me good accuracy. Tomorrow DeepSeek has come. It is even giving me better accuracy. But my solution is already running in production. What am I going to do, right? If I have to create everything from the scratch, it's going to take months again. So how do we do that? We modularize our architecture so that replacing one module is easier than creating everything from the scratch. Create your pipeline, right? Create your modules, and then wherever it's required, you can use microservices. And the modular architecture is very important. Second thing is human in the loop. Why it is important? Can we rely completely on agents yet? No, right? We have seen hallucinations. Hallucination is one thing, but if you talk about governance and compliance, right? For example, one of the cases where we were building a solution, HR solution for a company in New York, the recruitment solution, that the regulations and the law says for the recruitment or selection of any candidates, it cannot be 100% automated. We have to have a human judgment there, right? So that is one thing which is required, human in the loop. Second thing, how are you going to improve your systems? Because I know we have agent as judge, LLM as judge, which are there in the market, but giving the feedback in the system is always good. Human element has to be there, right? So because these LLMs are smart, but still not that smart that they can 100% give you accurate results, right? Or then we talk about the security part, which is basically giving the proper access control to protect the sensitive data. And this was, I think, Lakshmi also covered mainly on the monitoring and observability side. So if you're not able to monitor, track the performance of your model, how you are going to take the action, right? So as I was talking about, we are creating agentic AI solutions. Multiple agents are there. Agents talking to each other. If something is broken, it's difficult to find out where exactly it has broken, right? Until unless you are monitoring it, you are tracing each and every activity of the agents. And there also monitoring of the agent. One example again I'll tell you. So we were creating a agentic AI solutions where agents were talking to each other. There was one agent which was creating the report, another agent was reviewing it. Based on the, if it was passing, it was giving the feedback. The earlier agent was again working on that, and it went into infinite loop. Because it was giving the feedback, it was again working, then it was sending it back to the reviewer. That's how we learned it. Okay, probably we have to keep some, check on the number of times it has moved from one agent to another, right? So apart from accuracy, there are other measures also what we have to do while creating the solution, right? Then we say that plan for phased development and keep refining the accuracy, latency, and cost, which is, we all know that what we have, we should do it, but it becomes difficult, right? As I said, so when you create a POC, you don't actually think about the full-scale deployment. You somehow, try to prove, okay, whatever we are, as itself, name suggests, it's proof of concept. Once the proof of concept is done, do we actually write the code from the scratch again? No, right? Whatever garbage code we have created, we just try to use that because it is working fine. Any code which is working fine, we never touch it, right? And the same code we deploy it. So that's where our LLM ops and different tools which are there in the market, right? That's where we say, right, any deployment should not be manual, because when you are going to deploy your solution automatically, you are going to use any of the tools, right? For example, you must be using MS Copilot, GitHub repository. When you'll commit your code and it will go for deployment, obviously it will check for code quality checks, it will do, right? Your container scanning, it has to happen, right? So those things are, once you'll create the pipeline for everything, you will automate your deployments. I think those are the certain things what you can basically avoid it. Maybe for the first time, it's going to take 70% of your time, but from the next time, I think it's easy task for you. Then this is, again, the last part is very important. How you're planning to collect your feedback from the agents and the responses from the end users, because that's where and that's how you are going to improve your system, what you have created. So for that, generally what we do is we do short-term memory storage and long-term memory storage, right? So which is basically the feedback or the things agents can remember which has happened recently, which the memory which is in cache, right? Caching mechanism we generally talk, that's how we talk it, how you are going to use it. And for the long-term, where basically you are going to fine-tune your models, because short-term memory you are not going to fine-tune models, probably you are just going to fine-tune your prompts, not the models. But for the longer term, you can fine-tune your models. So as I was talking about the ML ops, LLM ops, and now these days it is agent ops, right? So again, I will not talk about each and everything, but the right side of the slide is important. Features of agent ops, right? And which is first thing is again important, agent creation registry, right? If you are not registering your agents, Because every time you cannot create new agents, right? Your agent, I know it is going to solve a problem if we can create a bit more generic agent and you have to create a registry. For example, I have deployed one agent in the production and then tomorrow I have come up with a new version, but I want to roll back to the earlier one. So if you are not registered your agents, it is impossible, right? It's very similar to the code registry, model registry, and now these days we are also having prompt registry. Similarly, we'll have to do for the agents as well, right? Then the guardrails, again, it's very important. Guardrails, because every company has different guardrails to follow. And for that also, I think we have created a solution and just use LLMs for all these things, what I'll say. But guardrails, again, these are, if you read your company's guardrails, must be 15, 16 or 20 plus pages of guardrails. Manually, it's not possible to do that, right? To wherever you are creating any solution and if you see, okay, are we abiding all these guardrails or not? Not possible. Create a solution for that. It's easy to create a solution and then, but you have to follow it because obviously we don't want to breach any of the compliances in the company or outside of the company as well. So now the thing is how we should be doing it. So for that, we have created a playbook for that because, right, my team versus the other team, the third team, fourth team, they are working. I know they are, all of them are working in their best way, but we want to standardize the process. That's how we created this EXL Agent X, the playbook. And it's important, it has been used by our customers also, which basically what we have created basis on the 20 plus deployments what we have done recently on agent side, which start with the process definition scope, then what kind of team you need to have it. This again is very important, right? Because as a team, you just don't need to have just data scientists, because apart from that, you need to have your MLOps engineer, your DevOps engineer, and ML engineer. Those are also very important, right? So now this part is important, and that's where most of the companies are investing these days, right? They are building their own agentic AI platform. What does it mean? In my company, I don't want, give probably, as I said, right? Me creating an agent versus you or someone else creating an agent, it can have a separate ways to create it, right? Which model to use, LLM model to use, which framework to use, that model is secured or not. So that's why the companies, what they are doing, they are building a platform where when you want to create any of the agents, they have created a module in the backend. We call it as Agent AI Builder, AI Agent Builder module, which is basically what it does. You just tell the platform, okay, I want to create an agent. Okay, it will ask what kind of agent you want to create. I'll tell in some verbiage, okay, this is the agent, this is the problem I want to solve. It will ask which LLM model. You can probably select it, whatever the compliant models have in the company, then which agentic framework you want to use, and tools, which is important, and then you can deploy it. So what problem it solves is basically, if you have created a template or this framework, then in the backend, it is easy to standardize the process of creating AI agents. It becomes easy to scale it because we know in and out about this, how the agents are being created, how these agents are being monitored, how we are monitoring the bias in the system, how we are monitoring the accuracy, hallucination, toxicity, and the cost as well. Because this is in the background, we are creating the agents using the tools and the whatever they have selected, but obviously they cannot select some random LLM model which is probably open source and they say, okay, no, I want to download it, I want to use it. Not really possible for the production deployment. For R&D purpose, they can do it, right? So if the platform I was talking about, right? So if you see, there are 4 main components of that. First is flexible cloud infrastructure. We are using any of the cloud sites these days. Everything is getting deployed on the cloud. One or the other, right? So it has to be flexible, which is basically you have to containerize your solution so that it can be deployed anywhere using Kubernetes, right? Then custom model development. We can create, some of the things can be standardized, but obviously you want to create something custom, it will give you that flexibility. Then the GenAI Agent Studio, which I was talking about, which is basically, you don't need to code it. It's kind of low code platform where the coding is very less required and you can create your agents. And then the enterprise solutions and agentic capabilities, basically stitching together these agents and creating your solution. This is the last slide, and this is, I think you must have seen multiple times. As a developer, if you are building a solution, creating something, right? That's how we start, right? With our stakeholders, which can be client, our teams, stakeholders, right? First, you understand the business problem, right? And when I say you understand the business problem and you create a proof of concept, which is POC, you never think that, okay, which agent I'm going to create. You always think about the solution, right? And that's where in the journey you identify whether what all tools, technology I should be using. Then the deployment, which is basically deploying to production. And while in this process, creating the pipeline, thinking about the DevOps, infrastructure as code, which becomes very important, because today probably you are solving one problem, but for the same company you can also solve another problem which can be very similar, right? So if you have created pipeline, you have used the way which automate your infrastructure provisioning, model deploying, it will be very easy. And then after deployment, which is basically scaling, which I was talking about, which is post-deployment, you have to monitor your system. Also, the way you have deployed it, you need to, review those systems. Then you can accelerate and optimize the system. So that's it from my side. I would like to have some question if anyone has. Lakshmi, you also come if anyone wants to ask any question. No question? Great. Smart audience. Thank you, everyone. Thanks for your time. Thank you so much.